We're going to continue with the notes that we have for section 5.3 that we started the other day in class. I'm anticipating tomorrow morning they're going to cancel school because of some crummy weather, and the video I have on this is kind of not so well focused, so we'll see if we can do better this time. So what we're going to be looking at now are the signs of trig functions. Notice signs, not sign like in sine cosine, but sign as in positive and negative. And as we've seen when we've looked at some of the trig functions in class, sometimes our trig functions have positive values and sometimes they have negative values. So we're going to see now where these come from. So let's take a little review of our XY coordinate plane. We know that in Q1 we have X's and Y's. Well, we have X's and Y's on the whole thing, but X is positive and Y is also positive. So Q1, X, Y, both positive. In Q2, now X is, we have the X, Y's again. X is negative and Y is positive. This is in Q2. In Q3, everything is negative. So again, we have our X, Y's. X is negative and Y is also negative. I guess I can put those guys in parentheses also, show their pairs. And last but not least, in Q4, quadrant 4, we have in our X, Y pairs, X is positive and Y is negative. So we've refreshed where X's and Y's are positive, and now let's take a look at this information and consider it in regards to our trig functions. So we know that, or hopefully you know, that sine of some angle theta is y over r. Cosine of some angle theta is x over r. And then tan of r theta is y over x. So these are the ratios that we've been using instead of opposite, hypotenuse, and adjacent. In regards to r, r is the length of our hypotenuse, or in terms of a circle, it's the length of our radius. So r is a distance, and r will always be a positive quantity. So r isn't going to be taken under consideration in our discussion of positive and negative trig functions because it's always positive. So in regards to sine, our sine is going to be positive when y is positive. Well, we know y is positive here in Q1 and Q2. So y is positive Q1 and Q2. And here, these are labeled. I can't take credit. Somebody else labeled them. But in Q1, we can see all our functions are positive. And in Q2, we can see that sine and its partner cosecant are positive. So this says sine is positive Q1 and Q2, where y is positive Q1 and Q2. Now let's take a look at cosine. Cosine is going to be positive since r is always positive, where x's are positives, and x's are positives here and here, Q1 and Q4. So cosine is going to be positive Q1 and Q4, and we can see that here. Q1, everybody's positive, all trig functions, and then in Q4 we have cosine and its inverse partner, its reciprocal partner, secant, always positive. Now, in terms of tangent, tangent is y over x. There is no r here. So tangent, the sign of tangent, again, positive, negative, is contingent upon the signs of y and x. So in Q1, where both x and y are positive, tan is also going to be positive. In Q3, where x and y are both negative, tan will also be positive because a negative divided by a negative is positive. So tangent is positive in Q3, and then of course its inverse partner, cotangent, will also be positive there. So this is the reasoning why sine, cosine, and tan have the positive and negatives that they do. And one way that somebody came up, not me, but I'll take credit for it, came up with to remember this is All students take calculus. So in Q1 we have all, Q2 students, Q3 take, and Q4 calculus. So all students take, whoops, just went over the next example, calculus. So a way to remember, in Q1, all your trig functions, everybody's going to be positive here. In Q2, it's sine and its partner cosecant positive, everybody else is negative. In Q3, it's take for tangent and its partner cotan positive, everybody else negative. And then in Q4, C for calculus, cosine and its partner secant that are positive, everybody else negative. In case you're wondering where all these students are taking calculus, they're at Quincy. Put a plug in for the school. Okay, so looking at first example of applying this, and I have written over that, but in your notes you can read it. Sine of theta is less than 0 and cosine of theta is less than 0. So what kind of numbers are less than 0? That's negative numbers. So what we're trying to find out here is, where is this angle theta? And what we're told is that the sine of theta is negative and the cosine of theta is negative. So where is sine negative? Well, sine's positive here and here, so it's negative in Q3 and Q4. So sine is negative down here where y is negative. Cosine is negative. Well, cosine is negative where x is negative, which is in this side, which is Q2 and Q3. So when we look here, we can see Q3, Q4, Q2, Q3. So the quadrant in common here is Q3. So our theta is in Q3. We're not solving for anything else here. We're just finding out where theta is, what quadrant it is. It's in. And then the last example in regards to this positive negative behavior, and also we're going to find some values, is we are told that the tangent of some angle theta is negative 1/3, and we're not told the value of its cosine. We're just told that the cosine is negative. So again here, this is a negative value that we're looking at. So first, let's consider the quadrants this activity is happening in. Tangent is negative. So tangent is going to be negative in Q2 and in Q4. If we look here, it's positive here and here. Whoops. It's positive here and here. So it's negative Q2 and Q4 tangent. Where is cosine negative? We already considered that in the example above, so no need to go over that again. Cosine is negative in Q2 and Q3. So we have in the quadrants where both of these functions are negative, Q2, Q4, Q2, Q3. So in this instance, we can see that the common quadrant is Q2. So we know that our theta is in Q2. So now we're asked to find the sine and secant, so we're going to need some values. When we are considering sine, the sine of an angle, we know that the sine of theta is equal to y over r. So we need a y and we need an r. Looking here at the tangent of theta, we are told that, let me write it here again, the tangent of theta is 1/3, okay? And we're told it's negative third. In our example, that negative sign is written right there in the middle of the fraction in front. And we don't know, is that negative sign in the numerator, is the negative sign in the denominator? We're not told that. We're just told that the whole fraction is negative. So To find out if it's the x or y that's negative, I mean, we can think about it, and what I'm going to do is I'm going to draw a picture to help us visualize it. Here, we know that this is y and this is x. So we know from here we're in Q2. So we're over here in Q2. Q2, I'll just label it. So in Q2, what happens in Q2? X's are negative here and Y's are positive. So what that means is that our X is the -3 and our Y is +1. So if we were to draw this, we would see we're going to go 1, 2, 3, and then here 1. So 1, 2, 3, 1, our point would be here. And then if we were to, so there is the point over here. Oops, can't see that. I need to look up more at the monitor. So here we have, I don't know where I lost it. So here, -1, 2, 3, x is -3, y is 1. Again, we didn't know where this negative sign applied, but we know we're in Q2. In Q2, x's are negatives and y's are positive. X is negative and y is positive. So now we know x, we know y, we need to find our r. R is equal to square root x squared plus y squared. In this case, x is -3. -3 squared is 9. Y is 1. 1 squared is 1. So we have 9 plus 1 is equal to 10. So r is equal to the square root of 10. So now we have all the information we need to answer the question. So going back here to our sign, sign is y over r. Y is 1 and r is square root 10. So we have 1 over the square root of 10, but we know whenever we have a radical in the denominator, we're going to rationalize. So this is going to be square root 10 over 10. And that is the sine of our angle theta. In regards to cosine, we know that, let me go back for a second. We know that secant is 1 over cosine. So, I mean, you could go right to secant, or if you just remember secant is cosine's partner, you can think of it that cosine of theta is x over r. So in this case, our x is -3 and r is square root 10. Again, rationalizing, this is equal up there. Rationalizing it, we have 3 square root 10 over 10. And that would be our cosine. But we don't want cosine. We want secant, which is the reciprocal of this. So secant of theta, we could think of it as r over x. And this would be square root 10 over -3, which you can see is just that flipped. So if it helps you to go to cosine first and then flip it, or if you want to go right to secant, you can. And so we have sine, we have cosine, we have secant, we have tangent. If we wanted to find cosecant, we would take the reciprocal of this. And for cotan, we would take the reciprocal of this. We weren't asked to do it, but just, oh, by the way.